Section 6.1 is solving systems of equations by graphing. A system of linear equations is two or more linear equations graphed on the same coordinate plane. Okay? Make sure you know what this terminology is. The solution of a system of linear equations is any ordered pair that makes all of the equations in a system true. So problem 1 is solving a system of equations by graphing. And we want to know what is the solution of the system. And here we have y is equal to 2x plus 4, and y is equal to x plus 2. So the way we find a solution is we graph both of the equations and we find where they intersect. So when we graph, what do we need? We need slope and we need a y-intercept, right? So for the first equation, we have, for equation 1, okay, our slope is equal to what? 2. And our y-intercept is equal to 4. For equation 2, our slope is equal to 1, and our y-intercept is equal to 2. Now, you're going to use that information to graph your equations. So, for equation 1, our y-intercept is 4, so we have 1, 2, 3, 4. And our slope is 2. So that's going to be up 2. I don't have any room to go to the right up there. It's going to be up here somewhere. So, or I could go down 2 and to the left 1. So down 2 and to the left. Remember, it's positive, right? So here is your graph. There is the graph of your equation. And don't forget to put your arrows on there. So there's a graph of the first equation. So now we're going to graph the second equation. So again, we started our y-intercept, which is 2. And my slope tells me to go up 1 to the right 1. Up 1 to the right 1. Up 1 to the right 1. Or we could go down 1 to the left 1. Down 1 to the left 1. And here's the graph for our equation. So there's the graph of your equation. And don't forget your arrows, because they go on forever in both directions. Now, where do they intersect? They intersect right there at what comma what? -2, comma 0. And there is a solution to your system of equations. All right. In order to check to see if that is the correct solution, you're going to take this x is -2 and y is equal to 0 and just plug it into your equation. So we've got 0 is equal to 2 times -2 plus 4. So that's 0 is equal to -4 plus 4. And that's going to give me 0 is equal to 0. That checks out. On the other one, we have 0 is equal to -2 plus 2. 0 is equal to 0, and that checks out too. So if you have an ordered pair that satisfies both equations, that is your solution. Is everybody clear? Now this system of equation, how many places does it intersect? just 1. Okay? So this system of equation has one solution. Got it? Problem 2 is writing a system of equations. Okay? So, write this problem down. Suppose one puppy weighs 5 pounds at birth and grows at a rate of 25 hundredths of a pound per month over the first several months. Another puppy weighs 4 pounds at birth and grows at a rate of half a pound per month. After how many months will the puppy weigh the same amount? All right, so when we look at the information we're given, we can use that to write our equation. So the first puppy weighs 5 pounds at birth and grows at a rate of 0.25 pounds per month over the first several months. What equation can you write with that? Y is equal to 0.25 x plus 5. Very good. Very good. I like to change the decimal to a fraction if I can, because of the rise over run. 1/4. Very good. So y is equal to 1/4 x plus 5. So there's my first equation. Right? Equation 1. Equation 2, let's see. Again, looking at our information, it says another puppy weighs 4 pounds at birth and grows at a rate of half a pound per month. So, y is equal to what?
Y is equal to 1/2 x plus 4.
Plus 4. Very good. So, we're going to change that decimal to a fraction. So we have our rise over run. So we have y is equal to 1/2 x plus 4. And there is our second equation. All right, so now we'll graph the first one in blue. All right, so we've got our slope is 1/4, and our y-intercept is 5. So we're going to start at 5 for our y-intercept, and the slope tells us to go up 1 and to the right 4. So we went up 1 and to the right 1, 2, 3, 4. Up 1 and to the right 4. Okay?
Why is the graph so big?
Well, I think I originally, see how there's 4 sections here? I originally was graphing the 0.25. So if you look at that, it would be up 0.25 and to the right 1. Up 0.25 and to the right 1. Up 0.25 and to the right 1. So that's where that would be. Okay? And then there's a graph of your line. Am I going to put let me ask you this. Are we going to put the arrows on both sides of the line?
No.
Why?
Because it was at birth 5 pounds and it can't go less.
Right. It's not going to go less than the 5 pounds. Theoretically, the puppy's going to keep on growing, right? So it's only going to go in the positive direction. Everybody good? All right, so for the second equation, I'm going to go ahead and graph with the decimal for that one too. Since it's, the slope is 1/2, and we're going, and the y-intercept is 4. Okay, so this time, my y-intercept is 4, and we're going to go up 1/2, right there, and to the right 1. Up 1/2, to the right 1. Up 1/2 to the right 1. Up 1/2 to the right 1. And there you can see where the two graphs will intersect. Okay? Where they intersect is where these puppies will weigh the same amount. So they intersect right here. So that's where they're going to weigh the same amount. And how much are they going to weigh? 6 pounds at how many months? At 4 months. Very good. So this is going to be 4, 6. This is at 4 months. Both puppies will weigh 6 pounds. You don't have to write this down, but I do want to let you know that problem 2 can also be solved by creating a table of values, right? If you put 3, 4, 5, 3, 4, 5, where they are the same here, 4, 6, 4, 6, that is your solution. You can also see the solution in a table of values. You got it? So, here we want to know, and we actually discussed this before we were recording. Here it says, how can a system of equations have no solution? Well, these are, this is more terminology. This is a consistent system of equations. If you have a consistent system of equations, then that is a system of equations that has at least one solution. Okay? It has at least one solution. That means one or more, right? At least means one or more. An independent solution has exactly one solution. Exactly one solution. A dependent system has infinitely many solutions. How did we say they were going to have infinite many solutions? If they were not just one line, 2 lines, but the same, they occupy the same space, right? 2 different equations, but they occupy the same space. And inconsistent is a system of equations that has no solution. And of course, how are we not going to have a solution? If they are parallel lines. Very good. Very good. All right, problem 3 is systems with infinitely many solutions or no solution. What is the solution of each system? And we want to use graphing to figure it out. So, again, here for letter A, we have the slope and we have the y-intercept, and we can just graph that. The slope is, for the first one, what? Slope is -1, and the y-intercept is -3. For my second one, the slope is -1. The y-intercept is 5. Same slope, different y-intercept. What kind of lines are those? Parallel. So, just going based on this, we're guessing that it is going to have, how many? No solution. Very good. So let's graph it. Okay? So, we're going to start for the first one, -3. -3 is right here. That's -3. And the slope is -1. So we're going to go down 1 to the right 1. Down 1 to the right 1. Okay? And there is the graph of your equation. Okay? The second one, the second equation is the y-intercept is 5. So we have 1, 2, 3, 4, 5. And the slope is -1. So we're going to go down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1. So for that one, There's a graph of your equation. And what kind of lines are they? They are parallel, just as we suspected. So these are parallel. Therefore, how many solutions? No solutions. When we graph this system for our letter B, let's see. My slope for the first one is what? 3. And the y-intercept is?
-3.
-3. Okay? So when we graph that, we're going to start at -3. 1, 2, 3. And the slope is 3. So that's going to be up 3 to the right 1. Or down 3 to the left 1. Very good. So there is a graph of your equation. Is my second equation in slope-intercept form?
No.
No, it's not, because it says 3y. Slope-intercept is y equals. So how do I get that 3 out of there?
You have to divide 3 on both sides.
On each term, right? So we're going to divide 3 here, here, and here. So my new equation then becomes y is equal to
3x
3x
minus 3.
minus 3. 3x minus 3. 3x minus 3. They are the same equation, which means that this second line it's a different equation. It's a different equation that occupies the same space, right? So it's the same line. Got it? So here we have 2 lines on the same, exactly in the same place. So how many solutions?
Infinite.
Right. This has infinite solutions. What kind of system is it? If this one has no solution, this one is what? This one is inconsistent. And when it has infinitely many solutions, that is a dependent solution. A dependent system, right? So we can also put that information in there. My graphs disappeared. Okay, so this one, I don't know, it's in there somewhere. All right, this one is infinite solutions is dependent system. Okay, and this one, the parallel, no solution means that this is a, what was it again? Inconsistent. Oh, disappeared again. Inconsistent system. Very good. Any questions?